Welcome to this comprehensive guide on C-sharp assemblies, modularization, and compile-time linking. These concepts are fundamental for building robust and efficient .NET applications. C-sharp assemblies are the core building blocks of .NET applications, acting as logical units of functionality. They package types and resources together, forming a complete, self-describing unit. Assemblies can be either dynamic link libraries or DLLs, which contain reusable code, or executable files, EXEs, which have a main method and can run independently. They are crucial for managing implementation details, versioning, and security within your .NET projects. Understanding them is key to effective development. Every assembly typically comprises four key elements: the assembly manifest, type metadata, MSNail code, and resources. Each plays a vital role. The assembly manifest holds crucial metadata, including version requirements, dependencies, and the assembly security identity. It's like an ID card for your code. Type metadata describes the types within the assembly and maps their implementations. This ensures the Common Language Runtime, or CLR, knows how to use your code. MSAL, or Microsoft Intermediate Language Code, is the compiled code that the CLR executes. It's the universal language for .NET applications. Finally, resources include embedded elements like images, icons, and XML files, which are integral to the application's functionality and user experience. Assemblies provide the CLR with all necessary information about type implementations, allowing them to execute within their own managed context. This makes assemblies manageable, versionable, and maintainable units, simplifying code reuse across different projects and facilitating component sharing. There are two main types of assemblies: private assemblies and shared assemblies. Each serves a distinct purpose in application deployment. Private assemblies are specific to a single application and are stored directly within that application's directory or a subdirectory. They are self-contained. Shared assemblies, also known as public assemblies, reside in a central location called the Global Assembly Cache, or GAC, allowing multiple applications to use them. Shared assemblies require a strong name and must be installed in the GAC using the gcutal command, ensuring their uniqueness and integrity. Now, let's explore modularization in C#, a fundamental principle for breaking down complex systems. This approach enhances code reusability, readability, and maintainability. Modularization allows for parallel work among development teams and simplifies maintenance efforts, making large projects more manageable. One key benefit is improved maintainability. Bugs or new features can be addressed within a specific module without impacting the entire codebase. Modules can be reused across different projects, significantly saving development time and promoting consistency. This is a huge efficiency gain. It also fosters better collaboration, as teams can work concurrently on different modules without stepping on each other's toes. Smaller modules are inherently easier to understand and debug, leading to faster problem identification and resolution. This boosts overall productivity. Finally, modularization enhances scalability, allowing individual modules to evolve independently as the system grows and adapts to new requirements. To apply modularization in C#, use namespaces to logically group related classes and structures. This creates clear boundaries and organization. Divide complex classes into smaller, more focused classes, each handling specific tasks. This adheres to the single responsibility principle. Employ dependency injection to provide required components to modules rather than hard-coding dependencies. This promotes flexibility and testability. Now, let's delve into compile-time linking, also known as static linking. This process occurs when the application is compiled, fixing code calls early. During compilation, the .NET compiler embeds version information of all used libraries directly into the program, ensuring consistency. In static linking, all necessary code is copied into the executable, creating a single, self-contained file. This contrasts with dynamic linking, which links libraries at runtime. While C# primarily uses dynamic linking, it incorporates elements of static linking through version checking and binding redirects, offering a hybrid approach. Remember, it's conventional for an assembly's code to reside in a single namespace or subnamespaces, with the assembly named after the namespace for clarity. Splitting large assemblies into smaller ones can reduce recompilation time, and always avoid loading multiple versions of an assembly into the same context to prevent type identity problems. Mastering these concepts will significantly enhance your C# development skills, leading to more organized, maintainable, and efficient applications. Thank you for watching.